Hello and greetings to everyone. We will continue from where we ended last time on the binary numbers. We are going to start by correcting the following exercise for application. Question 1 says, give two names for base 10. Write down solution. Question 1, you have to write down two names for base 10. The two names we know, decimal numbers or binary numbers. Those are the two names we have: decimal numbers or binary numbers. Those are the two names. Question 2 says, list all the digits used in base 10. In base 10, we make use of the digits. We make use of 0, 1, 2, 3, 4, 5, 6, 7, 8, and lastly 9. Since we are counting in groups of 10, we cannot make use of the number 10 or numbers above 10. So these are the digits you take note. Question 3 says, write down the following numbers in expanded form making use of index notation. For question E, we have the number 20,001. We know 2 here has a value of 20,000 plus, we are going to ignore all these zeros, plus 1 which has a value of 1 unit. We know 20,000 can be written as 2 times 10,000 plus 1 can be written as 1 times 1. This will simply give us 2 times, we know 10,000 in index notation. Index form will simply be written as 10 to the power 1, 2, 3, 4 plus 1 times, we know 1 in index notation is simply 10 to the power 0. We underline our answer. We're done. Next, for B, we have the number 111,101. 111,111. This will simply give us the first one has a value of 100,000 plus the second one has a value of 10,000. The next has a value of 1,000. The next has a value of 100. The next has a value of 10, and the last one has a value of 1 unit. This will simply give us 1 times 100,000 plus 1 times 10,000 plus 1 times 1,000 plus 1 times 100 plus 1 times 10 plus 1 times 1. This will simply be equal to 1 times, we know 100,000 in index notation will simply give us 10 to the power 1, 2, 3, 4, 5 plus 1 times 10,000 is simply 10 to the power 4 plus 1 times 10 to the power 1,000 is 10 to the power 3 plus 1 times 100 is simply 10 to the power 2 plus 1 times 10 is simply 10 to the power 1 plus 1 times 1 is simply 10 to the power 0. Underline the result. Next, we go to question C. We have the number 1,300,062. We know 1 has a value of 1 million. plus 3 has a value of 300,000 plus 6 has a value of 60 plus 2. We know 1 million can be written as 1 times 1 million. 1 times 1 million remains 1 million plus 3 times 100,000 remains 300,000 plus 6 times 10 gives us 60 plus 2 times 1. We know this is simply equal to 1 times 1 million is simply 10 to the power 1, 2, 3, 4, 5, 6 plus 3 times 100,000 is simply 10 to the power 5 plus 6 times 10 is simply 10 to the power 1 plus 2 times 1 is simply 10 to the power 0. Align our answer. Question D, we have the number 9,840,671. We know 9 has a value of 9 million plus 8 has a value of 800,000 plus 4 has a value of 40,000 plus 6 has a value of 600. We are going to ignore 0 plus 7 has a value of 70, then plus 1. This is the sum as 9 times 1 million plus 8 times 100,000 plus 4 times 10,000 plus 6 times 100 plus 7 times 10 plus 1 here can reach as 1 times 1. We know 1 is the multiplicative identity. That means when we multiply any number by 1, the result we obtain remains the same number. This will give us 9 times, we know 1 million is simply 10 to the power 6 plus 8 times 100,000 is simply 10 to the power 5 plus 4 times 10,000 is simply 10 to the power 4 plus 6 times 100 is simply 10 to the power 2 plus 7 times 10 is simply 10 to the power 1 plus 1 times 10 to the power 0. You know, 10 to the power 0 is equal to 1. We are done. Next, we go now to question 4, which says simplify the following expanded numbers. The first one for E, we have the number 6 times 10 to the power 3 plus 1 times 10 to the power 2 plus 5 times 10 to the power 1 plus 8 times 10 to the power 0. We know this will simply be equal to 6 times 10 to the power 3 is simply a 1 with 3 zeros, 1000, plus 1 times 10 to the power 2 is simply 1 with 2 zeros, 100, plus 5 times 10 to the power 1, a 1 with 1 zero, plus 8 times 10 to the power 1, 10 to the power 0 is simply 1. This will give us 6 times 1000 gives us 6000 plus 1 times 100 gives us 100 plus 5 times 10 gives us 50 plus 8 times 1 gives us 8. Next step we have to add. This will give us 6000 plus 100 gives us 6100. 6100 plus 50 gives us 6150. 6150 plus 8 gives us 6158. So this is our result. Next, now we go to question B. Unit number 6 times 10 to the power 4 plus 7 times 10 to the power 0. This will simply be equal to 6 times 10 to the power 4 is simply 1 with 4 zeros plus 7 times 10 to the power 0 is simply 7 times 1. So this will give us 6 times 10,000 will give us 60,000 plus 7 times 1 will give us 7. So if we add 60,000 plus 7, we are simply going to obtain 60,007. This is the result. We are done. Next, we go now to question C. Question C, we have the numbers 1 times 10 to the power 5 plus 3 times 10 to the power 2 plus 7 times 10 to the power 1. This will simply give us 1 times, we know 10 to the power 5 is simply 1 with 5 zeros, plus 3 times 10 to the power 2, 1 with 2 zeros, which is 100, plus 7 times 10 to the power 1 is simply 10. Next, this will give us 1 times 100,000 will give us 100,000, plus 3 times 100 gives us 300, plus 7 times 10 gives us 70. Next, we have to simplify. If you simplify, we have to add 100,000 plus 300 plus 70. We add 0, 7, 3, 0, 0, 1. So this will give us 100,370. 100,370. This will be our result. Next, now we are to answer question D. For D, we have 2 times 10 to the power 7 plus 4 times 10 to the power 5 plus 5 times 10 to the power 3 plus 3 times 10 to the power 2 plus 9 times 10 to the power 0. This will simply be equal to 2 times, we know 10 to the power 0 is simply 1 with 7 zeros, which is 10 million, plus 4 times 10 to the power 5 will give us 1 with 5 zeros, plus 5 times 10 to the power 3, 1 with 3 zeros, 1000, plus 3 times 10 to the power 2, 1 with 2 zeros, plus 9 times 10 to the power 0 is simply 1. Next, if we expand, if we multiply, this will give us take 2 times 10 million, this will give us 20 million, plus 4 times 100,000, this will give us 400,000, plus 5 times 1000 will give us 5,000, plus 3 times 100 will give us 300, plus 9 times 1, which is 9. Next, we have to add 20 million plus 400,000 plus 5,000 plus 300 plus 9. To add, this will give us 9, 0, 3, 5, 0, 4, 0, 2. This will give us the number 20,405,309. 20,405,309. Find the answer. We are done with the solution, the correction of the exercises. So next, we are moving now to the next thing we have to treat today, which is other number basis. I'll write it down here. Under this, we are going to treat base 2 and base 5. Let's take this down. We know a week A week has 7 days. If we are asked to count the number of weeks in 70 days, we shall simply count the days in groups of, let me make use of groupings of 7, which gives us 10 weeks. That means if we are given 70 days, for us to convert the 70 days to weeks, we'll simply count the 70 days in groups of 7s, or we simply divide the 70 days by 7, of which we are going to obtain 10 weeks. Counting, for example, the 70 days, counting it in groups of 7, counting in groupings of 7, is called base 7. It means when you count in groupings of 7, you're working in base 7. Remember the definition of a number base. Each number base has the same number of digits. If, for example, like in base 7, we make use of 7 digits. Let's write this down. In general, if we are working in base n, we make use of n digits. Next, I'll draw a table that carries the number base and the digits used in that number base. The first column we have number base. The second column we have the digits used in that number base. first one, if you take, if you are working in base 2, we make use of the digits 0, 1. In base 3, we make use of the digits 0, 1, 2. You'll see that the last digit is always less than the number base by 1. In base 4, we make use of the digits 0, 1, 2, 3. In base 5, we make use of the digits 0, 1, 2, 3, 4. Next, in base 6, we make use of the digits 0, 1, 2, 3, 4, 5. In base 7, we make use of the digits 0, 1, 2, 3, 4, 5, 6. It ends at 6. We are working base 7. In base 8, we make use of the digits 0, 1, 2, 3, 4, 5, 6, and lastly 7. In base 9, we make use of the digits 0, 1, 2, 3, 4, 5, 6, 7. Lastly, 8. 8 is the last digit. And base 10, we make use of the following digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and lastly 9. Remember, the Hindu-Arabic numeral system we treated is built in base 10. Next, now let's write this down. When working in a particular base, we always indicate the base as a subscript after writing down the digits. Let me write this down. Note. It's very important. When working in a particular base, we always denote the base as a subscript after writing the digits of the number. Writing the digits of the number. Let's take this in general. We are still under the note in general. A number. Let's take a number which has digits x, y, z, s, t. A number as such to the base n is written as, this is how we write this number to the base n. We write it as x, y, z, s, t, subscript n. This n which is down here is the base. when x, y, z, s, t are digits. Next, when a number is written without a base, by convention, that number is in base 10. Let me give some few examples. E.g., if we take this number, we can have a number 3, 2, 4, 2, which is in base 5 as a base. I have another number as such 1, 0, 0, 1, 1, which is in base 2. And I have another number as such 8, 7, 0, 4, 5, 6, which is in base 9, and so on. Next, when a number is written, without a base, then by convention, the base is 10. That's why when we're treating decimal or ordinary numbers, we never wrote any base by the side. So take note of that. Now we are going to take 2i. Remember, I was ordinary or decimal numbers. We are going to take 2i now, binary numbers. When you hear bi, you think of two things: binary numbers. Base 2 is called the binary system. In base 2, we make use of 2 digits, 0 and 1. That is, in this case, the counting is done in groupings of 2. Underline groupings of 2. Base 2 is widely used. In the world today because it makes use of only 2 digits. 0 and 1. These are the only 2 digits we make use of in base 2. It is applied to affirmations apply to affirmation and negation of statements. For example, I'll draw a table which carries some affirmations and negations of some statements. For example, draw a table as such. For the first column, I have 0. In the next one, I have 1, the digit 1. First one, I can use 0 for no, can use 1 for yes. Next, can use 0 for low. You can use 1 for high. Next, we can use 0 for negative. You can use 1 for positive. Next, we can use 0 for cold. You can use 1 for hot. Lastly, we can use 0 for on. We can use 0 for off. This one is very common in most machines. You can use 1 for on. Next, we are going to take now a subheading, which is conversion from base 10 to base 2. Conversion from base 10 to base 2. Means if we are given a number in base 10, we can change that number to base 2. Write this down: to convert a binary or decimal number, convert a binary or decimal number to base 2. We make use of repeated division by by 2, by the number 2, and recording the remainders. The result is the remainders grouped together starting from the last remainder to the first remainder. Let's take an example. On this. The example, it will be very easy for us to see it. Change the following base 10 numbers to base 2. For E, we have the number 9. B, we have the number 16. Lastly, C, we have the number 47. So we have to change these two binary numbers, these 3 binary numbers to base 2. We are going to make use of repeated division while recording the remainders. For the first number A, we have the number 9. For us to convert the number 9 to base 2, we are going to draw a vertical line as such. For the first column here, we are going to write 2, which is the new base. The second column, we are going to write down the number, the binary number we have to change to base 2, 9. And for the last column, here we are going to record the remainders. So we are going to put an arrow here for remainders. And we perform the repeated division. 9 divided by 2 gives us 4, remainder 1. We're going to write the 4 here. And we record the remainder here. Bring down 2. 4 divided by 2 gives us 2, remainder 0. We record the remainder here. We bring down 2. 2 divided by 2 gives us 1, remainder 0. We bring down 2. 1 divided by 2 will give us a whole number part of 0 and a remainder 1. This will give us a whole number part will be 0 and the remainder will be 1. We are done with the division. When we arrive 0, next we are to copy now the remainders from the last remainder to the first. This is the last remainder, that is from bottom to top. So we are going to put an arrow as such, indicating that this is the direction in which we have to copy the remainders. Therefore, the number 9 in base 2 is simply 1, 0, 0, 1. Then we must indicate the base, because if we don't put the base, by convention this number now will be in base 10, of which the number 1001 cannot be equal to 9. So we must put the base. We are done. We underline our answers. Next, question B. We have the number 16. We are going to repeat the same procedure. 2, 16. Then here for remainders. 16 divided by 2 gives us 8, remainder 0. We bring down 2. 8 divided by 2 gives us 4 remainder 0. We bring down 2. 4 divided by 2 gives us 2 remainder 0. We bring down 2. 2 divided by 2 gives us 1 remainder 0. We bring down 2. 1 divided by 2 gives us the whole number part of 0 remainder 1. We copy from bottom to top. Therefore, the number 16 in base 2 is simply 1, 0, 0, 0, 0, 0, 0, 1 with 4 zeros. Then we must precise the base in base 2 as such. Next, question C. For C, we have the number 47. The first column, we have 2. The second, we have the number 47. Then the third, we have the remainder. 47 divided by 2 gives us 23, remainder 1. 23 divided by 2 gives us 11, remainder 1. 11 divided by 2 gives us 5, remainder 1. 5 divided by 2 gives us 2, remainder 1. 2 divided by 2 gives us 1, remainder 0. 1 divided by 2 gives us 0, remainder 1. Then we copy the remainders from bottom to top. Therefore, 47 in base 2 is simply equal to 1, 0, 1, 1, 1, 1. Then we must write the base subscript 2. We are done. So that's how we convert from base 10 to base 2. Now let's take conversion from base 2 to base 10. Conversion from base 2 to base 10. Let's write this down. We have earlier seen that to expand a generic number, or decimal number, we break the number into powers of 10. For example, if we have the number 914, we know 9 has a value of 900 plus 1 has a value of 10 plus 4 units. We know this has 9 times 100 plus 1 times 10 plus 4 times 1. Which this will give us 9 times 10 to the power 1, 2 plus 1 times 10 to the power 1 plus 4 times 10 to the power 0. We know 10 to the power 0 is 1. Next, when we expand a number in base 2 in a similar manner in bracket. When we replacing 10 with 2. For example, in this expansion, if we were given this number in base 2, and in the place of 10 here, 10 to the power 2, instead we have 2 to the power 2, 2 to the power 1, 2 to the power 0. When we do something as such, we are going to obtain that number in base 10. We are converting the number from base 2 to base 10. Therefore, we convert a number in base 2 to base 10 by expansion. That means to open up by expansion of number in groupings or powers of 2. Let's note this. We take 2 to the power 0. 2 to the power 0 is equal to 1. 2 to the power 1 is equal to 2. 2 to the power 2 is the same as 2 times 2, which is 4. 2 to the power 3 is the same as 2 times 2 times 2, which is 8. 2 to the power 4 is the same as 2 times 2 times 2 times 2, which is 16. 2 to the power 5 is the same as 2 times 2 times 2 times 2 times 2, which is equal to 32. So we are going to make use of this when we are expanding numbers in base 2. Now let's take an example. Let's change the following binary numbers to base 10. For E, we have the number 1 0 1 in base 2. B, we have the number 1 0 1 1 in base 2. And lastly for C, we have the number 1 0 0 1 in base 2. So we have to change all these numbers to base. Then we're going to write down solution. We take for A 1 0 1 in base 2. We need to expand this number. This will simply give us the first digit, which is 1. Remember, the digit with the highest place value is always the first digit at the left hand side. So we start from the left hand side to the right. This will give us 1 times. We are working, this number is in base 2. So we are going to write 2 here. 1 times 2. This 2 will be raised to the power. We count the number of digits after 1. We have 1, 2. 1 times 2 to the power 2. Plus the next digit, we have 0 times the base is 2. 2 raised to the power means after 0 we have just 1 digit. Plus the last digit, which is 1, times the base is 2. After 1 there is no other digit. So 2 raised to the power 0. This will give us 1 times 2 raised to the power 2 is 2 times 2 plus 0 times 2 raised to the power 1 is 2 plus 1 times 2 raised to the power 0 is 1. Simplifying this will give us 1 times 2 gives us 2. 2 times 2 gives us 4 plus 0 times 2 gives us 0 plus 1 times 1 gives us 1. If we add 4 plus 1 gives us 5. That means the number 5 in base 10, when you convert 5 to base 2, you obtain 1 0 1. Let's go to B. For B, we have the number 1 0 1 1 base 2. This will give us 1 times the first digit 1 times 2 raised to the power 1 2 3 plus, for us to save time, since the next digit anywhere we see 0, we are going to ignore 0, because you know if you multiply 0 by any number, the result is 0. So plus, we go to the next digit 1 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. Because after this one, there's no other digit. So this will give us 1 times 2 times 2 times 2 plus 1 times 2. 2 raised to the power 1 is 2 plus 1 times 2 raised to the power 0 is 1. So this will give us 1 times 2, 2. 2 times 2, 4. 4 times 2, 8. Plus 1 times 1 gives us 2 plus 1 times 2 gives us 2 plus 1 times 1, which is 1. If we add 8 plus 2 gives us 10 plus 1, 11. That means the number 11, which is a generic number, when changed to base 2, you will have the number 1011. Next, let's answer C. For C, we have the number 10001. This will simply give us 1 times the base 2 raised to the power 1 2 3 4 plus all the other digits are 0 except the last digit, which is 1 times 2 raised to the power 0. This will give us 1 times 2 raised to the power 4 is 2 times 2 times 2 times 2 plus 1 times 2 raised to the power 0 is 1. This will give us 1 times 2, which is 2 times 2, 4 times 2, 8 times 2, 16 plus 1 times 1 gives us 1. 16 plus 1 gives us 17. Simply means the number 17, the generic number. When you convert this number to base 2, you obtain 10001. We can verify. If we take, for example, 5, let's convert 5 to base 2. Here we have our number 2, we have 5, and lastly the remainder. If we take 5 divided by 2, it gives us 2 remainder 1. We bring down to 2 divided by 2 gives us 1 remainder 0. Bring down to 1 divided by 2, we know 1 is less than 2, so the whole number part will be 0 and the remainder will be 1. Copy from bottom to top. Therefore, 5 in base 2 is simply 1, 0, 1. You can see the same. Now, we are going to end by taking down the exercise for application on this. Exercises for application. Exercises for application. Question 1 says, change the following numbers. Change the following numbers to base 2. Change the following numbers to base 2. The first one, A, we have the number 19. B, we have the number 59. C, we have the number 104. And lastly, D, we have the number 423. Question 2, change the following numbers to base 10. Take the first one, A, we have the number 100 base 2. B, we have the number 100 1 is 2. C, take the number 1 is 2. D, 1 is 2. So these are the exercises for application we have on this. Next, we are going to correct the exercises for application. Thank you very much for watching the video, and do well to answer the exercises.